Welcome back to Algebra 1 exercise sessions, chapter 1.8, page 34, and we are going to do number 22. Find the solution set. The replacement set is 0, 5, and 10. So we are going to replace 0, 5, and 10. Number 22, 1.1x is equal to x plus 0.5. We replace x by 0, so that this will be multiplied by 0. 1.1 times 0 is 0, is equal to 0, question mark here, plus 0.5. That's not true, so this is rejected. Replace x by 5, that will be 5.5 is equal to 5 plus 0.5, and that's accepted. So this is a solution. Now we replace x by 10, and 1.1 times 10, that's 11, is equal to 10 plus 0.5, and that's not true again. So this is also rejected, and our solution set is only number 5 in this case. Number 24, x squared minus 3x less than 10. Again, we replace x with 0. 0 minus 0 is less than 10. That's acceptable. Replace it with 5. 25 minus 15 is less than 10. Question mark. And when we minus, we get 10 less than 10. And that's not true. So this will not be accepted. And finally, we replace x with 10. X squared is 100 minus 30 less than 10, and that's also rejected. So the 5 and the 10 are rejected, and we only have 0 as an acceptable solution. Number 26, x squared minus 5x less than 100. Again, we replace x with 0. 0 minus 0 less than 100, question mark. And this is true, so 0 is acceptable solution. We replace x with 5. 5 times 5, here x squared, so it's 5 times 5, 25. Minus again here, 5 times 5, and that will be 25 less than 100. And this is true, 0 less than 100. So the 5 is a solution. Finally, we replace x with 10. X squared, that's 10 times 10, and that's 100. Minus 5 times 10, that's 50. Is it less than 100? And 100 minus 50 is 50. Is it less than 100? It is less than 100, so 10 is an acceptable solution. So in this case, our three numbers are solutions for this inequality. Number 27, x squared plus 7x equals 3x plus 45. In this case, we replace x again with 0, so 0 plus 0 equals 0 plus 45. Now we put question mark, is it equal to this? So now we find out that 0 is not equal to 45, so 0 is not a solution, so it is rejected. Next, we replace x with 5, and that will be 25 on x squared. 7 times 5, that's 35, is equal to 3 times 5, that's 15, plus 45. And we add, so that will be 10, 60. Is it equal to, again, to 60? And the answer is yes. So this is a solution. 5 is a solution. Now we replace 10 x with 10, and that will be 100 plus 70. Is it equal to 30 plus 45? And 170 is not equal to 75. So this is rejected, and we accept only 5 as a solution to this equation. Now we come to number 34 and 35 and so on, the red colored numbers. Here we are requested the following. An open sentence can contain more than one variable for each sentence. Tell whether it is true for all numbers. If not, give an example showing it is not. Number 34, x plus y equals y plus x. Is this true for all numbers? Yes, it is true for all numbers. Whatever number you put for x or for y and you add them, you are going to find out that x plus y is equal to y plus x. And this is the commutative property of addition. You can replace x and y with any number. So this is a true statement. Number 35, we are going to put it below this for comparison, x minus y. This is a false statement. X minus y is not equal to y minus x. For example, replace x with 5 and y with 3. And that's not equal to 3 minus 5. So this statement is false for all numbers. Number 36 is x plus y minus y is equal to x. Y minus y is 0, so I'm adding 0 to x, and the result will be x. So this is true for whatever number we choose for x or y. So if you replace x with, let's say, 5 and y with 3, so you're going to have 5 plus 3 minus 3 equals to 5. 3 minus 3 is 0, add it to 5 will give you 5. So this is true for whatever number you replace x or y with. Number 37, is this statement true for all numbers? Here this is a different situation than the previous ones. Here we have squaring of x, and if we square a fraction, half times half is going to be less than the original fraction. So half times half is not more than half. We are going to get 1/4. So this statement is not true for all numbers. Definitely it's not true for the fractions as we have seen. For other numbers, whether it is positive or negative, this statement will be true, except for 0 also will not apply. So for 0 and the fractions, this statement does not apply. Number 38, x into y minus z equals to xy minus xz. This statement is true. It's just the definition of the distributive property. You are distributing x over y and z. So this quantity here is equal to these two quantities subtracted from each other. So this is true for all numbers. Number 39, x times x. Again, is this true for all numbers? Here we have x squared less than x squared plus 1. So whatever is x, then I square it, and then I square it on the other side, and I add 1, then this quantity is going to be more than this quantity. So this is true for all numbers. We'll do a number examples, which is in number 42. 2x plus 3x plus 4x. So on one side we have 2x plus 3x plus 4x equals to x plus 8x. Here we have a replacement set, which is 1, 2, 3, 4. You can right away see that we have 9x on this side and 9x on the other side. So whatever the value of x, these two quantities are going to be equal. So if I replace x with 1, 2, 3, or 4, these two sides of the equation are going to be equal. So if this is the replacement set, is also the solution set. So let's replace one number only. Let's do number 2. 2 times 2 plus 3 times 2 plus 4 times 2 is equal to 2 plus 8 times 2. Here we have 4 plus 6 plus 8 equals to 2 plus 16. This is 10 and 8, 18 is equal to 18. And the same will apply to all these values. Now the number 43 is slightly different. Here, instead of having 2x, we have x plus 3x plus 4x is equal to x plus 8x. And we are given this replacement set. This cannot be true for any number because you can see right away that we have 8x on one side and on the other side we have x plus 8x. Unless x is 0, so we are going to have 0 equals to 0 plus 0. Otherwise, for these numbers, this will not fit. We are having a quantity, the same quantity on both sides, and in addition we have another quantity added to it. So they cannot be equal unless, as we said, x is 0. So if we replace 1, 2, 3, or 4 in this equation, none of them is going to work. Let's try number 2 again. So 2 plus 6 plus 8 equals to 2 plus 16. And here we have 10 and 6, that's 16, equals to 18, which is not true. So this is going to be rejected. Same with the 1, 3, and 4. So in this case, our answer is a null set. So this is a little bit different than the previous one, where any number would fit. Here, none of these numbers would fit, and the answer is a null set. With this, we come to the end of this session, and we hope to see you again.